Today we will start with Vant of factor. And in this we came to know about abnormal masses also. My dear, as you all know, we have discussed about colligative properties. So, colligative property is directly proportional to the mass of solute. You all know this. We have discussed 4 colligative properties, and all those properties were directly proportional to the quantity of solute. Suppose, and we have discussed till now all the cases of non-electrolytes, which means they do not dissociate into ions. For example, I am taking this beaker and I am adding water in it. After that, I am adding sugar. And we all know sugar does not dissociate into ions. So there is no problem in it. Okay? Its colligative property is directly proportional to the mass of the solute. But if I am taking NaCl in water, you know NaCl dissociates into Na plus and Cl negative. Okay? NaCl dissociates into Na plus and Cl negative. So my dear, here your colligative property is not, your theoretical mass of that colligative property will not become equal to the observed value. Okay, so I will take 2 cases. Like one case is association and other case is dissociation. For that, first I am going to introduce this Vant of factor. This factor is represented by I, and this factor is helpful in, is defined as the, there are different definitions of this factor which we comes to know later on. So first I am taking the case of dissociation. Suppose I am taking this beaker in which water is added and I am adding 1 mole of NaCl in it. Okay, in this beaker I am adding 1 mole of NaCl in it. As you all know, NaCl will dissociate like Na plus and Cl negative. But in all the colligative property, we were taking the case of non-electrolytes. So suppose when we start the reaction at 0 second, suppose there are 1 mole of NaCl present in this reaction mixture. So it is not dissociating. So these Na plus and Cl negative are 0. And at time t, suppose after 15 seconds or at any time t, it is completely dissociated. Suppose it is completely dissociated. As you see the balanced equation, when we are taking its 1 mole of Na and 1 mole of Cl negative is formed. So 1 mole of Na plus and 1 mole of Cl negative will form at time t. Simple, is it? It is dissociating. We are expecting that theoretical colligative should come equal to 1, but actually it is equal to 1 plus 1. So here comes our Vant of factor whose value is equal to observed colligative property, which is this, in this case, over theoretical colligative property. Okay? What we are expecting, what is actually coming. That is your Vant of factor, which is in this case comes out to be 2 over 1. It is expecting and it is actually coming. So it will be 2. In case of dissociation in this particular case, whose value is equal to observed colligative property over theoretical colligative property. Or you can say that experimental value of colligative property over calculated value of colligative property. What we are expecting, what we are getting. Okay? Now, there might be another case also, that is case of disassociation. There might be a case of association. Suppose one molecule is associating. In this case, suppose I am taking acetic acid. It undergoes dimerization. Suppose I am taking 2 molecules of CH3COH and it dimerizes in benzene to form 1 molecule. Okay, it dimerizes. Suppose I am taking 100 and it will form 50 because it undergoes dimerization. Okay, it undergoes association. So, in this case, suppose at T is equal to 0, I am taking 100 molecules of this. So, it will be 0. And at T is equal to T, suppose it is left 0 and what it will form? 50. Although this will not happen because it is not the strong acid. It is weakly associated. It is weakly dissociated. And then undergoes association. So, I hope is it clear to you? Now, what we are expecting 100, what we are getting 50. So, in this case, I will be observed colligative property over theoretical. So, this is our Vant of factor in case of dissociation. My dear, from this, if I will ask, what will be the effect of amount of solute in case of association? See, we are taking 100 molecules and we are getting 50. It means if I make table association and dissociation. First, I will take molecule quantity of solute, value of I, and you can also take colligative property. See, in case of association, the quantity of solute decreases because it undergoes dimerization. Value of I will be less than 1. And colligative property will also decrease. In case of dissociation, like I was taking NaCl, it dissociates into Na plus and Cl negative. Number of ions will increase. So quantity of solute will increase and I will be greater than 1. Like in particular last case, it was 2. and colligative property will also increase. So my dear, to rectify the different masses of elements, we have to introduce this Vant factor in all of the colligative properties. Likewise, suppose first colligative property is relative lowering of vapor pressure is directly proportional to is equals to molar mass, mole fraction of solute. So if I will introduce Vant factor here, then these two quantities become equal. Otherwise, this property will not give the exact value. Second is osmotic pressure. Pi is equal to CRT. Here, Vant factor should be introduced. Third was elevation in boiling point. This is abelioscopic constant. This is molality. This is elevation in boiling point. And fourth is delta TF. Is this I KF into M. It is cryoscopic constant, molality, depression in freezing point, and Vant factor. Vant factor value, you know, it is observed colligative property over your theoretical colligative property. Or in terms of molar mass, I can also be calculated as your normal molar mass, which we are expecting, and abnormal, which is coming from the experiments. You can also calculate from this formula also. Observed molar mass or normal means calculated molar mass over abnormal means observed molar mass. It is represented as calculated molar mass over observed molar mass. This is another formula for calculation of Vant factor. Okay. Is there any doubt till now? Please let me know.